Okay, hi everyone. Can you all hear me?
Yes, madam.
Okay. Okay, it's already 10. However, there's only 40 of you. It should be 100. So I think I should wait for another 5 to 10 minutes. Okay, hi everyone. I think I should start now. Hi, why would there were just 56 of you? Are you all in campus right now?
No, madam. I'm at home, at my hometown.
Oh, so is it all of you in campus or okay, some of you, okay, some of you in campus. Okay, I think I should start now. Can you see the slide?
Yes.
Okay. Okay, now you are currently in chapter 2. Not we have not done yet. There's a 9 subtopic. So I will continue the subtopic on Cartesian vectors. Okay, and then the addition and subtraction of Cartesian vectors. So for chapter 2, the objective is just only 3. So today I will cover the objective on force and position in Cartesian vector. So we will look at the magnitude and the direction. Okay, for the subtopic of Cartesian vector and addition and subtraction, this is the objective that you should achieve, which is you all should know how to represent a 3D vector in a Cartesian coordinate system. And then you all should know how to find the magnitude and the angle. Okay, for today, it is on 3D vector. For example, like this one, you can see the truck. There's a x, y, and z axis. So it is in a 3D. So you should all use the right-handed coordinate system. It refers to the 3D vector. Okay, for example, in this application, this is the 3D vector where it shows in a real life. So how you want to find or how you want to find the resultant force of this cable? So later I will show you how. Okay, another one in this application. As you can see the cables, there's a 1, 2, and 3. This situation is in a 3D form. So how you want to find the forces that react at this cable? And how you want to find the resultant force so that this tower is stable and not moving, right? So now let us look at the unit vector. Last week you have learned on the magnitude. Do you know the difference between magnitude and vector? This one you have learned during foundation. So the magnitude is the value of this vector along this vector. For example, there's a how many meter? 3 meter. So that is the magnitude. And then the vector is the main how to say it? The vector is the arrow here shows direction, and then the value is the vector. Okay, so a unit vector is equals to vector over magnitude. So vector, the A is bold, and then the magnitude in italic shape. Okay, a unit vector shows you value of one magnitude. So it is dimensionless. So the direction is the same like the original vector. Later, when we use this formula, you will know what is the unit vector. So for now, you just memorize it. A unit vector is equals to vector over magnitude. Okay, next let us look. Okay, of course you all know that for x-axis, the the Cartesian unit vector is I, and then for y-axis is j, and then for z-axis is k. Okay, if you have a force, or if you have a vector A, like this one, you should imagine it is in a box shape. Okay, because today we are learn about the 3D. So you just imagine when the vector A is the direction is upwards like this, you imagine the shape is in a box. Okay, a rectangular box. Or maybe square, I'm not sure, but later when there's a value, you will know the shape of the vector. But currently, you just imagine it is in a box shape. Okay, and then the component for vector A is equals to ax plus ay plus az. Okay, if you want to find the vector A here, it is equal to the value of ax plus ay plus az. So when you transform it into a Cartesian vector, it would be axi for x-axis, and then ay for ayj for y-axis, and then azk for z-axis. So you can write it like this. A vector A is equal to axi plus ayj plus azk. So this is a common Cartesian vector that you have known, that you have studied during the foundation. So I'm sure you're master in it, right? Is it okay until now? Okay. Now let us look at the next one. Okay. Magnitude. Okay, what is the magnitude? Magnitude is the value along this vector A here. What is the value? So how you want to find, for example, the maybe cm. How many cm of this vector? How you want to find it? So you have to use the magnitude of Cartesian vector. So the formula for magnitude Cartesian vector is ax square plus ay square plus az square. In this situation, in this formula, it is the summation of x, y, and z. Why? Why? Because it is in 3D. So if the graphic is in 2D, there would be no z. So there's only left x and y. So in this situation, it's 3D, so you have to plus az square. I'm sure you all know the formula for magnitude of Cartesian vector. Okay, and then, okay, just now you have find the coordinate, right? The coordinate for this vector A. And then now you have find the magnitude of the vector A. So which means the length of this vector. And then now you need to find the angle of this vector A. So how you want to find the angle? You have to use this bottom formula, which is where you want to find the direction of the Cartesian vector, the angle. There's a alpha, beta, and gamma. Okay, where is the alpha, beta, and gamma uh show you? In which part? There's a three degree or three direction. So which one? Which one is alpha? Which one is beta? Which one is gamma? Yeah, good. The arrow correspond to each axis. Okay. For alpha is for x axis. So it would be like from x axis until A. Okay, this one is alpha. And then beta is for y axis. So at y axis until the vector A. So this one is beta. Oops. Okay. And then for gamma is for from z axis until the vector A, because we are in a 3D 3D system, so that's why there's a three angle or three direction. Okay, so um so now you know the direction or the angle of this vector A, and then this one where you want to find the length or the value of this vector A. For example, this one vector A, so you know the value of this vector A. This one shows you magnitude. And then for the direction, the angle formula here shows you the direction or the angle value of the vector. So the previous one that I show you the previous slide. Okay, sorry. This one is the value where the vector is. So at the end, at point here, the coordinate of the vector is, you have to use this formula. So there's three important things, which is the Cartesian vector form or the coordinate. Number one, the coordinate. Okay, now let me change the color. Okay. Okay, number one, you need to find the coordinate. Okay, the coordinate of the vector. Second, this one second, you need to find the magnitude, which means the value of this vector. Number two. Okay, this one is number three. You need to find the angle or the direction where the vector is. So number three is the angle. The angle value is the number three. So the three main point you all should know, and then of course the formula as well. Okay, how you want to relate the alpha, beta, and gamma. So in summation, you should use formula of cos square alpha plus cos square beta plus cos square gamma is equals to 1. So if you want to check whether the angle is correct, you can use this bottom formula. Is it correct or not? Okay, now okay, this one the one that I showed you before. Where is the alpha? Alpha is from x-axis until the vector, and then for beta is from y-axis until the vector A, and then gamma is from z-axis until A. So make sure for alpha you need to use ax, the vector at x. And then for beta, make sure you use Y. For gamma, make sure you use Z. Okay. Okay, this range value of the angle or the position is around 0 to 180 degree. Okay. Okay, just now I show you right the formula for unit vector. U is equal to vector over what vector A over magnitude A. So for vector A, this one is equals to the coordinate, which is AXI plus AYJ plus AZK. So you place this coordinate into the vector A. So the equation would be AX over the magnitude AI plus AYJ over the magnitude AZK over the magnitude AK. Or you can write it in another way, which is this formula is equal to cos alpha I, because AX over A is equal to cos alpha. Have you noticed it? This one, the one that I showed you before. Cos alpha is equal to AX over A. So when you write it in another way, or you convert it, so it would be cos this cos alpha is equals to AX, cos beta is equal to AYA, and then cos gamma equal to AZA. So later you will use this formula. So how you want to when you are going to use this formula? It depends on the question. Sometimes they give you angle, so you need to find the magnitude. Some question they just give you magnitude, so you need to find the angle, and then you need to find the direction. Direction is angle, and then you need to find the vector unit. So that's why there's a various way how to write the formula. Okay, because some information will not be given, so you need to try to what you call that? You try to use the formula given, but before that you need to actually find what is the value for each component in the formula. Is it clear until now? I'm sure you all blur, right? Okay, maybe we can try later the example question so it would be clear. Okay, now this one, the one that I show you. Okay, I will remind you back. For cos alpha is equal to AX over A. So the alpha is from x-axis until vector A. So the AX is the value along the x-axis. So the A is the magnitude. So AX over A, you will get cos alpha. It is also like a trigonometry. Have you remember? Theta, and then for me I label it as T, S, and H. So if you want to find the cos, you can see that side over hypotenuse. So AX over A, right? That's why you will get the angle alpha. This one is a trigonal actually. Using so for beta, AY over the magnitude A. And then for gamma, AZ at z-axis over A. So how you want to check it is whether correct or not the angle, you can use the next formula. It must be equal to 1. Okay, some question maybe just give you alpha and beta. You need to find the gamma. So how? You can use, maybe you can use this formula, or you can use this formula if the value AL is that given and the magnitude given. If not, you need to find the magnitude, you need to find the vector AZ, then you will get the gamma. Okay, if you want to check whether the gamma value is correct or not, you should use this formula. It must be equal to 1. Okay, now let us look at next case. This one, additional and subtraction vector. This one you have learned during mathematics. Mathematics and physics. Physics also, you have learned Cartesian vector, right? So, the Cartesian vector is ijk. The coordinate of ijk. This one vector A. Vector A coordinate is axi plus ayj plus azk. Then vector B equals to bxi plus byj plus bzk. Okay, if the question show you A plus B, so you just add according to the same component. Okay, this one is I, so you just plus AX plus BX for I component. For I component, Z component, J component, and K. So just plus it. And then for A minus B, you should minus A minus BX, AY minus BY, and then AZ minus BZ. Don't forget whether to check the negative and positive. Okay. This one I think I'm sure you all know. Very simple. Okay. Okay, some 3D information. Just now like I said, right, the question maybe just give you magnitude and the coordinate, or maybe the question just give you magnitude and the projection angles. So you need to find the direction. So it depends on the question. You just have to memorize the formula and make sure you know how to use it. Okay. Okay, for example, this is the Cartesian form, Cartesian vector form, where there's a I, J, and K. Don't forget the unit. Okay, this is Cartesian form. Just now I just show you A, B, C, D, right? So in real situation like cable, the application that I show you, the cables in the tower, there's a force. So force is the vector. So you just write it as F equals to what? IJK. And then don't forget the unit Newton. Okay, this is example of the Cartesian vector form in real situation. Okay, now let us look at example 1. Okay, in example 1, given here there's a two forces which is F1 and G. So there's a F1 and G applied to a hook. So there's a hook here. Force F1 is shown in the figure and it makes 60 degree angle, okay, with the x and y plane. So from x and y plane, 60 degree. Force G is pointing up and has a magnitude of 80 kilonewton. Okay, and then the value given here is alpha beta. So in our situation, it is in a 3D. Make sure you look carefully. It is in a 3D form. And then the angle for G just alpha and beta. So how does the G, or how where the G pointed up to? Okay, now you need to find the resultant force in the Cartesian vector form. So make sure you transfer all the forces here to the Cartesian vector form, which I, J, K. So you need to find the coordinate first, or the position. If you then later you can find the resultant force. So the plan is you need to use the trigonometry to write the F1, G in the Cartesian vector first. And then you can add F1 and G because you want to find the FR, right? FR is equal to F1 plus G. So before that, you need to find each of these vector, the Cartesian vector. You need to find the F1 equals to what I plus what J plus what K, and then for G as well, what I plus what J plus what K. So how? How are you going to find it? How are you going to find it? Okay, first let us find the F1. Oh, I think I should. Hold on. Should use pen, right? Can I just write it here? You need to find F1. Okay, F1 first. F1 equals to what I plus what J plus what K. So how are you going to find the I? Where is it? F for I, for I is this in x-axis. Okay, the direction is in x-axis. So how are you going to find it? Can you see it?
Can madam?
Yeah, you want to find the F1 X. How you want to find it? How you want to find it? So the shape is like this. So you want to the angle is 45. One is 45. This one F1 X. So do you remember trigonometry? Theta, T, H, and S. Okay, in this situation, you need to find the vector that next to the angle 45. So it should be cos theta over the side value, which is f1x, over the hypotenuse. Hypotenuse is f prime here. So how you want to So you did not know f1x and f1 prime. So you need to find the f1 prime first. How you need to find it is refer to the origin one. f1 100k. This one is hypotenuse, and then angle 60, and you can find the f1 prime. So you need to find this. Let me clean. No, not this one. You need to find the f1 first. So the angle would be like this, right? Okay. 160 is 100. So you can find the value at the bottom here. So which formula? Side and hypotenuse. So you should use cos. Okay. So the first one, cos 60 degree, you will get f1, f prime over the hypotenuse 100. So for f1 prime, f prime is equal to 100 times uh, cos 60, you will get 50 kilonewton. So now you know the f1. Let me change the color. Okay, now you know the f1 here is 50. This one is 50 kilonewton. Then you can find the fix. So the angle, okay, number 2, the angle will be like this, 45. And then you know this one is 50, and then this side. So you have to use cos, diagonal for cos. So it would be cos 45 equals to side, the f1x over 50. So now you will get the f1x is equals to 50 times cos 45. It is 35.36 kilonewton. Okay, now you can write it because you find the value here, so you can transfer it to the vector f1. So you get 35.36. Okay, please make sure you check back. Is it positive or negative, the direction for f1x? Is it positive or negative?
Positive, madam. Positive.
Yeah, so you make sure you write, you don't have to write. It's negative, so you need to write. Okay, now you have find the f1x. You need to find next as f1y. So f1y. Okay, you need to find the at this point, point number 3. You need to find here. So the triangle is opposite. So for opposite, you need to use sine. Okay, for number 3, the figure is like this, 45, 45, and then you know this one is 50. So you want to find the opposite. So the opposite is sine. So sine 45 equals to f1y over 50. So if 50 times sine 45, you will get equals to 50 sine 45. Then you will get the answer is 35.36. Okay, now you put it back the value 35 here, 35 on this point. So it will be 35.36. Is it positive or negative? Yeah, it is negative. You can see this one. F1y, the side is negative. So don't forget to put negative. Okay, how about K? K, you need to find K. Okay, let me change the color. Which color? Yellow. Orange. Okay. Now we need to find the F1K. Where is it? F1K. Which one? Which one? F1K. Okay, F1K is at this point here. Number 4 here. So if you want to find this, yeah, it's same thing. You need to use trigonometry. So number 4, one is 60. This one is 100. So you will get opposite. So opposite is sine. So sine 60 over the F1Z over 100. So F1Z is equals to 100 times sine 60. Then you will get the value is 86.6. So this value you should put at this part here. So 86.6. Is it positive or negative? For Z. Yeah, for it is positive. So you get the full coordinate for this vector, which is 335.36i minus 35.36j plus 86.6k. So now you have done for F1. So you have next, you need to find the coordinate or the position for G. Okay, is it clear until now? Before we go to the next one.
Mm.
Okay.
Clear, madam.
Okay, yeah. Uh-huh. Okay, this one, the same thing what I show you. I need to find the coordinate for F1 first. Now we need to find the position G. Okay, how we want to find it? Okay, let me clear the screen first. Hold on. Okay, now we need to find the G coordinate. Okay. The information given here is 80 kilonewton. So the magnitude is 80 kilonewton. And then given here alpha 1111 and beta is 69.3. So alpha is from X until G. Me. Okay, you need to get this one. Alpha is 111 and then beta from y-axis is 69.3. Okay, you need to find the angle, the gamma first. So how to find it? Make sure you refer back to the formula. The formula is cos square alpha plus cos square beta plus cos square gamma is equals to 1. So you need to find the gamma first. You know okay, you know the alpha, you know the beta, then you can find the gamma. So you just fill in back cos square alpha is 111 plus cos square beta is 69.3 plus cos square gamma unknown 1. So you just use your calculator. Okay, then you will get cos square gamma equals to 0.7467. Then you rearrange this equation, so later you will get the gamma is equals to 30.22 degree. Okay, now the next step is you need to find the position, the vector for this G. Okay, it is easier when you find the angle for the third angle, right? Now you need to find the position. I think I should clear the screen first. Okay. Okay, now you know the gamma is just now is 30.22 degree. Okay. You need to find the G, the position for G. So for G is equal to what I plus what J plus what K. You need to find at point I first. Okay, in this situation, the value, what are the value given? Just the angle, right? Angle and the magnitude. So how you want to find it? How you want to find the IJK? Okay, if you refer to the unit vector U is equals to vector A, for example, vector A over magnitude A, right? In this situation, magnitude were given, and then you need to find the magnitude. No, the vector. The vector is the position I, J, K. So when you arrange, if you can see the force, when you arrange this formula, so it would be go upwards. So it would be AT U equals to A. U is the IJK. So when you write it into the Cartesian vector, all of this equation need to times 80. So So before that, you need to find the coordinate at point I or at the x-axis, x-axis, y-axis, and z-axis. So how you need to find it? Please refer back to the notes. If you can see, if you refer back to the notes, where is it? If you want to find the coordinate. Okay, let me get back to you. The previous note. This one. U A is equals to cos alpha I plus cos beta j plus cos gamma k. So you just use cos 111 degree plus cos what is the value for beta just now? Beta 69.3 and then plus the one that you find cos gamma. So cos 30.22. So let me get back to you. Okay. So it would be so it would be equals to 80 times 1 cos alpha. Cos alpha is 111 I plus cos beta. Cos beta is 69.3 plus cos gamma. Cos 30.22 K. Then don't forget the unit. What is it? Kilonewton. Okay, then you times all this one. 80 times cos 111, 80 times cos 69.3, 80 times cos 30.22. So each of it, you will get the value. What is the value? I think this one is negative, yeah. Negative. Cos 111 times 80 would be? Can anyone try to calculate it? Cos 111 times 80. So we will get negative 28.67 I plus 28.28 J plus 69.13 K. Don't forget the unit kilonewton. So now you know the position for G. Next step is you need to find what? Need to find what? Now you know the position for F1, you know the G. Okay, yeah, you need to find the total, which is the resultant force. FR equals to F1 and F1 plus G. So you just plus it. Just now you know the position for I, you know position for G. So you just add both of it. So at the end you will get the FR is equal to 6.69 I minus 7.08 J plus 156 K. Don't forget the unit kilonewton. Okay, this one you know the position, but how about the magnitude? This one is just a position or the coordinate. You can find the magnitude. The formula for magnitude is for FR is 6.69 square plus negative 7.08 square plus 156 square, and then square root. You will get the magnitude value. Okay, now you know the position, you know the magnitude. But how about the angle? How about the angle? How you want to find it? So you need to refer back the formula, because you know the position, you know the magnitude, but where is the angle for the resultant force? So you need to use the formula. The formula just now that I show you, right? Cos, this one. You can use back. Cos alpha, cos beta, cos gamma. We just use it back. So you should use cos alpha equals to the vector. Vector is for resultant force is 6.69. So 6, I think I should use another color. Okay. Cos alpha equals to 6.69 over the magnitude. What's the magnitude value for this one? Magnitude value is 156.3. Okay, this one, this value, the magnitude value is 156.3 kilonewton. So you just use back the equation that I showed you before. Cos alpha is equals to the vector at x over the magnitude at x. So now you know the angle for alpha. What is the value? Can anyone try to calculate it? Are you sure? Let me try 6.69 over 156.3, and then shift cos answer. You will get 87. One is 87.546 would be 5 lah, degree. Okay, now you know the alpha. You need to find beta and gamma. So, where should I write? I should write here. Where should I write it? Okay, now cos beta. Cos beta is equal to this point here, which is negative 7.08 over magnitude value is 156.3. So you get the beta. Beta is okay, 92.6. So beta 92.6. And then you need to find gamma. So cos gamma equals to the value of the resultant force is 156. 156 over the magnitude is 156.3. So you get the gamma value. 156 over 156.3. Shift cos. Okay, 3.55. Yeah, 3.55. Okay, where did I get 156.3? It is this one, the magnitude, the resultant force magnitude. The magnitude. Is it clear, Xia Cheng Hui? You need to find the magnitude. You must look back this formula. Cos alpha is equal to vector over magnitude. So this is at the final stage where you need to find the resultant force or the summation of the force. So you need to find the vector from the resultant force. So this is the resultant force value over the magnitude. This one, the magnitude value. Okay. Now you know the coordinate, which is the position, and then you know the magnitude, which is the length of the force, and then now you know the angle value. Okay, by using the cos of beta and gamma. So you have done, you have complete. You know how to solve the example 1. Okay, now let us look. Is it clear until now? Is there any question? Okay, Yo Chong. Okay, for beta, did we need to have negative 4 degree? Yes. While you do the calculation, you need to write the negative. This one, the negative. Don't forget. From here, you will know whether the angle, if negative, for sure is over than 90. So the direction will be slightly from the, if this one is beta, so it would be over than the, maybe at this point. So make sure don't forget the negative. Okay, now is there any question? Okay, y angle between f1z and f1 is 60. It is given here in the question. The 60 degree were given. In the figure. Have you seen it? Please refer to the notes. Can you see the 60, this one? The question also given F1 is shown in the figure and it makes 60-degree angle. No. Patricia, we should refer to the question where you need to find the resultant force. It is not just the highlighted area. We only have the coordinate area only. I mean for F1. Yeah, if you want to find the F1, you need to find the coordinate for F1, right? So the coordinate must be relate to F1x, F1y, and then F1z. How you want to find it? So you imagine the vector here in a box shape, right? First you need to imagine it is in a box shape. So in the box shape, at the bottom here you can see there's a F1, F, and Fx. So you need to find the position at this point. How you to find the position? That's why you need to that's why it is color in blue here. So you can imagine there's a box. You need to find the F1x and then F1y. So you have to use trigonometry rule. Is it clear? Okay, for f1z, it is at this point. f1z. Is it clear? Okay. You need to find the position first, the coordinate. That's why f1x, f1y, and f1z. It depends on the question. This one is just an example. Some question they will not highlight it in blue like this. They just give you arrow. So you need to imagine. You need to find the coordinate where the vector is. Okay, next we will look at the example 2. Okay, if you can see here, the screw eye is subjected to two forces, F1 and F2. So you need to find the magnitude and the coordinate direction, angle of the resultant force. So you need, actually at the end, you need to find the resultant force. You need to find the coordinate, you need to find the magnitude. Same like the one that I showed you before. So you need to find the Fr equals to F1 plus F2. So before you solve this F1 plus F2, you need to find each coordinate. F1, the I plus J plus K. And then for F2, you need to find the coordinate F plus J plus K. Okay, and then from here, when you find the coordinate, you can find this one, the first one, coordinate. Second, you should find the magnitude for the FR. When you plus both of this, you need to find the magnitude. So it's one I plus what, J square, there's no I. I mean the position is I, and this one for J plus what square for K. So now you know the coordinate and the magnitude. From here, you need to find the angle. Same like what I showed you before. So you can try it on your own. Hello? Can you all hear me? Suddenly I just disconnected. Okay.
Yes, doctor.
Okay. Now, I think you can do it on your own. This example 2. It is same like example 1. So you can try it on your own. Example 2. Okay, before we go to the next subtopic, which is on position vector and force vector. Okay, I will take a break for three minutes. Is it okay? Okay, let us take a break for 3 minutes. Okay, hi everyone. I'm back. So, can I continue? Okay.
Yes, doctor.
Okay, good. Okay, now our next subtopic is on position vectors and the force vector directed along a line. Okay, it is the same objective under objective number 2. Okay, for example, I'm sorry. So the today objective is you all should know how to represent a position vector in Cartesian coordinate from the geometry. For example, this one geometry, you all should know how to represent the position vector in Cartesian. And then you all should know how to represent a force vector directed along a line. Okay, for example, in this application, in this plane here, there's a wing strut. So how you want to find the force that react at this wing strut?
Doctor, I can't see the slide. Sorry.
Oh, sorry. I didn't click the share button. I'm sorry. Hiya. Where is it? Where is it? Okay. Can you all see it now?
Yes.
Okay. I didn't click the share button.
Happy
Okay.
birthday, Soleh.
Okay. Now. For example, okay, you need to find the forces that react at this wing strut. So how you want to represent the forces that react at this beam or at this wing strut here? So later I will show you how. Okay, for position vector, of course you all know at this point, for example, A, B, and C, there's a coordinate, right, for each point. So you need to find the coordinate for X, Y, and Z. In this situation, there's 3D. So there's a I, J, and K. So later in chapter 4, you need to use this knowledge where to find the moment of the force. So that's why you need to learn the basic first. For example, at point A here, what is the coordinate for point A? What is the coordinate for point A? It is 2, and then Y is 4, and then the Z is 6. So 2, 4, 6, right? The coordinate for A. And then how about B? What is the coordinate for B? You need to find the position vector. What is the coordinate for B?
0 to 0.
0. Why does the value? Y is 2. Y2, Z0. Yeah, correct. And then how about C? C. The coordinate for C. C is 6, 1, 4. 6, 1, 4. Yeah, 6, negative 1 and 4. So the position vector is 6i, negative 1j, and then positive 4k. Yeah. Okay. So where is my pen? I've lost my pen. Okay. For example, this coordinate is just now is 6, negative 1, and 4, right? If you change this coordinate into a position vector, it would be 6i minus 1j plus 4k. Okay, now same goes to others, B and A. I'm sure you all know this one. Okay, lex. This one what I showed you before. The coordinate for x, I, y, j, and z, k. Okay, if there's a 2 point, which is point A and point B. So you know the coordinates, right? For A, for example, x, y, z, A. Then for B, x, y, z for B. So you need to find the direction vector from A to B. So how? It also same as the B minus A, where the tip minus the tail. So xb minus xa, yb minus ya, and then zb minus za. So this is the position vector for the direction from A to B. I'm sure you all know this one as well. Okay, for example 1, let's see here. You need to express the position vector R. So this vector R here, labeled as R, in Cartesian vector form. So make sure there's a I, J, K. Then you determine its magnitude. So we need to find the magnitude along this AB vector here. And the coordinate direction angle. So you need to find the angle, the magnitude, and the position. So there's a 3-step. Not 3-step, 3 things that you need to find, which is the Cartesian vector, 1. And then you need to find the magnitude, 2. And then you need to find the coordinate, 3. The same thing like last chapter, last subtopic, where you need to find the position. Okay, first you find the coordinate for point A here. What is the coordinate for A? What is the coordinate for A? Can anyone tell me the coordinate for A? Point A, what is it? What is it? And coordinate for point B, what is it? What is the coordinate for A?
1, negative 2, 1.
Okay, 1, negative 2, and 1. Yes, correct. And how about B? How about B? What is the coordinate for B?
4, 4, negative 1.
Okay, 4 and then 4 and then negative 1. Yeah, correct. Okay, now you know the coordinate. You need to change it into the Cartesian vector. You need to change it into a Cartesian vector form. So this one would be A equals to I minus 2j plus k. And then for B is 4i plus 4j minus k. Okay, now you know the Cartesian the the Cartesian vector for A and B. However, you need find for R the position for vector R. So what you need to do? Because you want to find R, Cartesian vector for R, I, J, and K for R, Cartesian vector. How to find it? How to find it? Can anyone tell me?
B minus A.
Yeah, you need to B minus the A. R is equal to B minus A. One is R A B, right? So you need to minus B and A. Each component must be the same. 4 minus 1. So 4 minus 1 for I plus 4 minus negative 2. This one for J. Then plus negative 1 minus 1 and K. So you will get 4 minus 1 is 3i plus 6j and then minus 2k. Okay, now you have find the first one, Cartesian vector for R. Next, you need to find the magnitude of this RAB. What is the formula for magnitude? The square root one. The square and then the square root. So for magnitude is equal to RAB equals to 3 square plus 6 square plus negative 2 square and then the square root. And you will get the magnitude. What is the value? It is 7. But don't forget to write down the unit. Okay, first point, also this one, don't forget the unit. 1 meter. And this one magnitude also meter. Okay, next step you need to find the coordinate. The coordinate. How to find it? Okay, you need to find the coordinate direction. This one. You need to find point 3. Okay, 3.3 here. How you to find it? How to find the coordinate? Okay, you refer back. In this situation, it is in a 3D. So the 3D must be, there's a alpha, beta, and gamma. So you write it back, cos alpha equals to the vector for I. I is 3. So 3 over magnitude. Magnitude is 7. So you write it back, 7. Then you will get the alpha value. Alpha would be 64.6. Then you need to find beta, cos beta. Also for beta is J component. So J component for resultant is is 6. So you write 6 back. 6 over magnitude is 7. Then you will get the beta. Beta value is 31 degree. And then next, you need to find gamma. I don't have much space here. So cos gamma equals to what? What is the one, the value here? What is the value? You want to find gamma. Must be positioned at K. What is the value for K? Yeah, -2. -2 over the magnitude is 7. Then you will get the gamma value is 106.6 degree. So these are the 3 steps, or the three component, or 3 section that you need to find. Well, it is a Cartesian vector, magnitude, and coordinate. So is it clear until now? Okay, is it clear until now? Okay, is there any question?
Doctor, how to determine the alpha, beta, and gamma if it's negative or not?
Okay, if you want to find the alpha, beta, gamma, the value vector is referred back to the resultant force position. If this here mention negative, then you must take negative. Is it okay?
Is alpha, beta, and gamma always positive or what?
No, you must refer
Right.
to you must refer to the value that you
The
get
vector.
from the vector here, Cartesian vector. Don't leave the negative. If there's a negative, please take it while you do the calculation for, if you want to find the degree. Please don't leave the sign positive or negative. Okay, and then
Okay, thank
next.
you.
Okay. Is there any question? Okay, now let us look at the next slide. Okay, you can look back how I do, how I solve the question just now. This one you need to find the position vector and the magnitude and then the coordinate. Okay, next we will look at the okay, Muhammad Amir, I still confused where is the position of alpha, beta, and gamma. Okay, I've shown you before in. Have you referred to the notes that I upload in Ulearn, Muhammad Amir? If you look at it, there's a alpha, beta, and gamma sign. Okay, for alpha is from x-axis until the vector r. Okay, if you can find here, you need to find the FR. FR coordinate is 3 plus 6 minus 2. So the angle is from x until the r. This one is alpha. Okay. And then for beta is from y-axis until the r. And for z, from z until the r, vector r. Okay. Now let us look at the force vector directed along a line. So if the force vector is directed along a line, same like this, where the force is the same as the unit vector. So you can write it as F equals to F times the unit vector. This is the one that I showed you before. Right, the question where there's a 80 kilonewton times U. So the force is equal to 80 U. It's the same like what I show you in question, in example 1, last topic, not this topic. Okay, for example, this one, there's a chain here. Okay, how we want to find the unit vector for each change? Okay, there's a force. So how we want to use it? It's like the example 1 from the last topic that I show you. So let us see example 2. Okay, in this example 2, we express force F as a Cartesian vector. Determine its coordinate, direction, angle. For how you want to find it? First, you need to find the coordinate at point A and point B. Then you can find the resultant force. So how the resultant force is? Okay, let me see the coordinate for A. So you just name it the coordinate for A. What is the coordinate for A? B is simple. Coordinate B is simple. The coordinate is 4 and then 1 and then how about Z? Z is 0. So if we change this into a Cartesian vector would be 4i plus 1j and then there's a 0. There's no k. And for B. Okay, how about A? How you to find A? How you to find it? You have to use the trigonal rule. 60 and 2 the opposite and side. So you need to use, okay, which one? So if you want to find x direction, which one? What is the value for x? For A, x is 0. There's no value, there's no coordinate at x. So x is 0. And then how about y? I want to find the value for y. It is the opposite of 60 degree. So for if you want to find the opposite, you have to use sine. So sine 60 equals to y over the 2. So y is equals to what? Can you use your calculator? 2 times sine 60. 1.73. Or you can write it as set 3. Set 3. Value is set 3. And then you want to find a position at z-axis. It would be side. So if side from the 60 degree is cos. you need to use cos. So cos 60 equals to side value over 2. Then you will get 1. So 0, sub 3 and 1. This is the coordinate for A. You need to change it into a Cartesian vector. So the position for Cartesian vector would be 0i plus sub 3j plus 1k. So now you know for A and B. You need to find the resultant force. So resultant force is where B minus A. Okay, if you want to minus it, 4 minus 0, you will get the R A B is equals to 4 minus 0 I, and then plus where is it? 1 minus sub 3 for J, and then 1 I'm sorry, where is it? 0 minus 1k. So then you will get 4i plus 2.732j, then minus 1k. Now you know the RAB. You need to find the magnitude. What is the magnitude? The rule for magnitude is I just write lah. 4 square plus 2.732 square plus minus 1 square root. Then you will get the value is 4.946 meter. And now you know the position and then you know the magnitude. You need to find the coordinate direction in angle. So how you want to find it? You can use the value for cos alpha beta, right? But before that, you cannot directly find it using the cos alpha, beta, and gamma. You need to time it with 400 kilonewton. So the formula would be F R equals to F times U. So it would be, how you to find the U? The F is 500. How about U? U, if you refer back to the previous note, U is equals to, what is it? The resultant coordinate, this one. Okay. The resultant coordinate over magnitude. So for FU is equals to 4i plus 2.732j minus 1k over magnitude. What is the value for magnitude? 4.946. This one. Okay, then you will get each component. For I is 0.8087i plus 0.552j minus 0.202k. Then you should times it with you need to time it with 500. So this value you need to times with 500. YA coordinate is 0. What do you mean? H1? H1? What do you mean? Okay, let me continue. Okay, now you need to times with 500. Okay, this vector unit here. So 500 times 0 0.8081 and then 87, then 500 times 0 0.552, then 500 times minus 0 0.202k. So at the end you will get the FR is equals to 404I plus 276J minus 101K. So now you know the FR, but still you did not find the direction angle. So you can later use the formula cos alpha equals to the vector for I is 404 over the magnitude. What is the magnitude? You need to find the magnitude. The magnitude for the U. This one, you did not find the magnitude yet. So you need to find it. For U, this one. 8087 plus 0. 0.552. What is the magnitude? So you need, before you want to find this, you need to find the magnitude. 0.8087 square plus 0.552 square plus minus 0.202 square. So it would be, let me calculate. 0.8081 square plus 5.552 square plus 0.202 square and square root. Okay, you will get 0.999. So you place it back 0.999. So the alpha would be 404. Okay, cos also. Okay, then you will get alpha is 36. Okay, for beta, if you refer to notes, you will get 56.5. And then for gamma, you will get 102 degree. So I have shared you in the, okay, what is it? For I at point A. Okay, for point A, the x is 0. You can see how the question show you, the figure show you here. Okay, you can refer to the notes I share you the solution. Same way, the way I show you just now. Okay, you need to find the coordinates, and then you need to find the position vector, and the magnitude, position vector, and the coordinate, and then the unit vector. Because why? Why you need to find the unit vector? Because there's a value f given. If there's no f, you don't need to find the unit vector. But there is a value f here. That's why you need to use, or you need to find the unit vector. Okay, and then that's why from the unit vector, you need to times with 500. This one, the u value that you find just now. Because there's a f given here. Okay, from here, this value, you will get the alpha, beta, and gamma. So this question, you can try it on your own. We don't have time. Okay, I think I need to do a replacement class, extra class, not replacement. I need to do an extra class so that I can finish chapter 2. There's only one part, and then I need to finish chapter 3. So at what time you all available to do the extra class? So at what time you prefer to do the extra class? Okay, tomorrow night. Oh, no, Friday. How about Friday? Friday night. Is it okay? Friday. Friday night or Friday morning? Oh, you all have tutorial class. Friday cuti, why? Why Friday cuti? Oh, night you have quiz. I need to finish chapter 3 and this chapter 2. Tomorrow night. Tomorrow night, some of you cannot. Okay. Okay, I will, it's okay, it's almost 12. You have class after this, right? Let me decide it. I will post it in ulearn. So please refer to the ulearn. Okay, about the quiz, yeah, it should be quiz 1 this week. Let me check. I think there's a quiz 1. Hold on, let me check. Quiz. Yeah, it should be quiz 1. So quiz 1 is in objective form. Which time do you prefer? Math 6 p.m. Saturday. 6 p.m. Friday night? Friday night, do you have anything? Friday night. Friday at 6. Oh, 6. I cannot on Friday at 6. Okay, I will decide it, and then I will type it in. I will announce it in Ulearn. So if you have any argument, or you can type it in the forum. Tutorial at the moment it is online. At the moment tutorial is online. Okay. You have class after this, right? It's already 12. So I will announce it in Ulearn. Please look at it from time to time. Okay. Focus 1, 2, 3. So I will inform it through Ulearn. It's already 12. So I will end the class now. You have class after this, right? So I will end the session now. Okay, bye-bye. Please look at the announcement in Ulearn. Okay, bye-bye. Bye-bye.
Thank you so much, doctor.
Yeah, welcome. Bye-bye.
Uh,